Okay, this is going to be section 9.4, which is entitled Borrowing Money. So now we're going to be finally considering this case about earning interest on things, on loans, like things that you've purchased, like with a credit card, or maybe a loan for a car loan, or a mortgage for a home. Um, Very interesting section here. So, first, though, the first 3 pages are just giving us some background about specifically how credit cards work. And I was gonna just kind of assign it as like a assigned reading kind of thing, but I think it's so important that I'm literally going to read this to you and kind of talk about, like, interject with my own thoughts as we go along. So I'm going through page 497 through 499 will be the pages that I'm going to read, and then of course I'll start with the actual lecture and do some math. Okay, so credit cards, right? Just as interest worked in our favor when saving money, borrowing money can make interest work against us. Okay, so in other words, when we're gaining interest on purchases through a credit card, we are the ones paying the interest to the bank instead of like a savings account where they're paying us interest. So this says most savings accounts offer an APR of 10% or less. In fact, I'd emphasize or less, right? However, when borrowing money, institutions often charge a much higher rate of interest, and you see these much higher rates, which that sucks, but that's just how, I guess, just how it works. It says in some cases the interest rate can soar even higher if payments are missed or are late. So there are things that can happen where if you miss a payment on a credit card, you get charged a penalty APR, a penalty percentage rate. So they'll raise it, and possibly also charge you a late fee. Okay. So, first of all, I think most of y'all probably know this this is kind of an old textbook, so they emphasize the difference between debit cards and credit cards. Just in case you don't know, a debit card is not like a loan. Like, you're not borrowing money when you use a debit card. A debit card is just like digital money that is yours, right? A credit card, though, is when you don't have the money. You're borrowing the money from the bank. Okay. So I'll skip that, reading through that paragraph explicitly. Credit cards work on the principle that money is lent out for a month. Money is lent out for a month. If the money is not repaid in full at the end of the month, so a balance remains at the end of the month, balance meaning you owe a balance on the card, then a charge of interest is incurred upon the balance. Okay. So during that month when no interest is being added to the balance, that's called a grace period. The grace period is a period of time in which no interest accrues on a debt. Accrues on a debt. Is that the right pronunciation? Anyways, however, if a balance is carried over to the next month, then interest will start to gain until the balance is back at zero. The interest rate on a credit card is often a variable interest rate, meaning that it can change. It can fluctuate, like I said, based on, like, if you're late, it can go up. It also depends on our country's prime rate of interest. I don't know a whole lot about that. That's something that you could research on your own. Okay. So in this picture here, we have annual percentage rate for purchases and then annual percentage rates for cash advances. So you see the APR is much higher for cash advances. Okay. Let me scoot this book up a little bit. Okay. Now, this minimum payment business is pretty interesting. Using credit cards wisely means that you only charge what you can afford to pay off in 1 month, right? So that you won't gain interest, ideally. If it is the case that you cannot pay off the balance by the end of the month, then you must make a partial payment. Okay. You have to make a partial payment, otherwise you'll get penalized and get charged more money. A minimum payment is the minimum amount the lender requires you to pay each month, usually equal to some percentage of your average balance due, say 2%, which seems low. And you might say, well, that's nice. Maybe the bank's being nice and they're saying, look, you only got to pay 2%, right? You only got to pay 2% of what you borrowed each month. That's the minimum payment. But let's dig into that a bit more and investigate. So if your average daily balance for a certain month is $1,000, so you have $1,000 balance on your credit card, meaning that's how much you owe, your minimum payment will be $20 because that's 20% of, that's 2% of $1,000. Many people assume that it's a good deal to pay $20 per month in order to pay off a debt of $1,000. However, that debt is gaining interest. So your $20 is paying off interest, not necessarily the balance, right? It's a lot of your $20 per month is going to be going towards interest. It says if the interest rate is as high as 20% on the balance owed, which it could be, the 20% payment each month goes almost completely towards interest and has very little impact on that balance that you're trying to pay off. So when they require that you only pay a small, like a minimum small percentage each month, they're actually extending the time that it's going to take you to pay it off. In other words, they're gaining more of your money over time because you're going to have to, the longer the balance extends, the more interest you're going to end up paying. Okay. Let's look at like an explicit example here. Figure 2 is a graph showing the payment line for a $1,000 credit card balance with 14% interest, where the minimum payment due is 4% of the balance each month. This is assuming no new additional purchases are made. You're just trying to pay off this $1,000. It takes 6 years for the balance to get just below $120. And at that point, so the balance, this 4% is based off the balance, and the balance is always shrinking. So now 4% of $120 would be less than $5. So at that point, the minimum payment, so this is assuming you're only paying the minimum payment each month, it would be less than $5 per month. And you may say, well, that sounds good. That means I'm not paying that much. But the minimum payment size is going to keep shrinking, and at some point there's got to be a cutoff, because otherwise you'll just keep going infinitely long. The interest will keep gaining while you keep trying to pay it off, and you end up in this loop, right? So to prevent it from reaching this point where you'll never actually completely go to zero, the credit card company will have set an overall minimum payment amount that will eventually force you to pay the balance in full. But look at how long it would take, right? It takes a long time to pay off if you're just paying minimum payments. So they say, let's contrast that with a different picture of making payments. Suppose the same $1,000 debt was paid off monthly with a consistent payment of $40 per month. So they model that for us here. I'm running out of space because of the way my desk is set up. I can't get the book in here. But you'll see you get to zero in only 31 months, much shorter time span, if you're making fixed $40 per month payments. Okay. And here are those two graphs superimposed upon one another. So the minimum payment at the very beginning was $40, because that's 4% of 1,000, which is this example we're looking at. The blue line represents a changing minimum payment. So a blue line is when you just keep adjusting to whatever their minimum payment is that they're telling you to pay. The red line is sticking with that $40 per month the whole time. You see how much faster you pay it off. This means you're paying less, right, over time, because it's going to be gaining, it has less time to keep gaining interest. So people I think the general public didn't really know about this, like how messed up it was. for them to only charge some kind of minimum payment to extend the amount of time it takes you to pay it off, and thus extending the amount of interest. So then apparently in 2009, there was this law passed that had bipartisan support that protected consumers from shady stuff like this. So now, if you get a credit card bill in the mail, it's going to have some information like this on here. First of all, it's going to tell you about late payment warnings. See, your APR can increase, a penalty APR, if you're late, right? So they increase that interest rate that you're gaining if you're late. And a late fee, just a late fee added as well. And then here it says minimum payment warning. If you only make the minimum payment each period, you will pay more interest and it will take you longer to pay off your balance, for example. And then they give you some data here. It says if you only make the minimum payment due, it's going to take you 7 years and you will pay this much altogether. If you make $60 per month, you're going to pay it off in 3 years and you're going to only pay this much altogether, which means a savings of, that much. This is based off of like someone's data, right? Someone's credit card account, right? So that's what this bill, this Credit Card Act did, is it made it necessary for credit card companies to tell you this sort of information on your statement. Okay. Now we get into the actual math. And the very first formula is that crazy looking logarithm formula that I do want to work an example with, but I'm not going to require that you guys do, because again, we haven't talked about the math of logarithms. Okay. So, here is the statement. We can use the following formula to calculate the number of fixed payments required to, this is a mouthful, to pay down a debt that is gaining interest monthly and here it is. So this tells us the number of payments that you would need, number of fixed payments, so not changing payments, but fixed payments required to pay down a debt that is gaining interest monthly. We call it R, so that's the number of fixed payments, is equal to this crazy fraction thing with logarithms in it, so negative of log 1 minus R over N times A over the size of the payment, A being the amount owed, and divided by log of 1 plus R over N. So A is the loan amount, payment is the, of course, size of payment, little r is the APR, N is the number of payments per year. Usually it'll be like monthly, right? So N will usually be 12, number of payments per year. And capital R will be just total number of payments. Let's practice using this formula. or really, let me just show you how the formula is used with an example. Okay. Assume you want to buy a new computer that costs $2,200, and you're going to use a credit card with an APR of 19.99%. How long will it take to pay off if you make $40 monthly payments? And what about $80 monthly payments? And we'll investigate the difference between those two. Not just how long it'll take, but how much more you'll end up paying in one case versus the other. Okay. When they say how long will it take, what I'm going to do is I'm going to use this formula up here to get the number of payments that I'm going to make that are monthly, and then this will be some number of payments, monthly payments, and then I can divide that by 12 to get the number of years it'll take. Right? This will tell me how many months it'll take, and then I can get number of years too. I can get it in months or years. This will give me time in months. This will be the number of fixed payments per month. So then if I want it in years, I'll just divide by 12. Okay. So I'm going to say R is equal to negative log. So log is just a mathematical operation that I'm not really getting into right now. APR is 0.1999, dividing that 19.99% by 100 to get it as a decimal. N is 12 here. A is $2,200 over payment is $40. Close that bracket, parentheses, log of 1 plus that APR over monthly payments, 12, and being 12 here. Okay. So in the calculator, in the calculator, I'll say negative log, there's the log button, of 1 minus 0.1999 divided by 12, and then I'm going to say times, wrap this in parentheses, 2,200 divided by 40, close that parentheses, close the second parentheses, that should be my numerator, and then divided by log of 1 plus 0.1999 divided by 12, close that parentheses, and I'm getting R is equal to 150.076, I'll just say 0.08 monthly payments. I should say approximately, right? Monthly payments. Since I rounded, I should say approximately. Okay, and how many years is this? So that's 150 months, so divided by 12. So T then is approximately 12.5 years to get it as a number of years. Okay, So I answered the first question, how long will it take to pay off if I make monthly $40 payments? By the way, how much am I paying in total? Well, how do I figure that out? I do my $40 payment times the number of months. I'll just say 150 just to make it easier. I made 150 payments. Oh my goodness, look at that. $6,000 for a laptop, or not laptop, a computer that costs $2,200. Okay, let's try the other case. So I'm going to cover this up and we'll do the $80 monthly payment. So basically, same calculation except that 40 is going to be replaced by 80. R is equal to negative of log 1 minus APR is 0.1999 over 12 for n, and then that amount, the loan amount is still $2,200, and now instead of dividing by 40, I'm dividing by 80, all over. So it's still monthly payments, and the APR is the same, and the loan amount is the same. Everything's the same except for that monthly payment there. So I'm getting R is approximately, ooh, you know what? I wonder if it's saved. Haha. Negative log of 1 minus, I'm literally going to change one digit here. Instead of 40, I'm going to say 80. Okay, that'll be my numerator, and I'll have to redivide here. Divided by log of 1 plus 0.1, oops, 1999. Divided by 12, close that. Ooh, look at that, much less. R is approximately 37.08 monthly payments. Oh, there, 37.08 monthly payments. Divide that by 12 to get time. Time is approximately 3.09 years. Much less time, right? What was time for the other one? It's 12 and a half years versus 3 years. And how much total was paid? Well, I made $80 payments per for $80 per month payments for 37 months. I'll just round to 37 there, and I'm gonna get 80 times 37 is giving me $2,960. So clearly, it's better to make bigger monthly payments so that you pay off your debt faster. So you pay off your debt faster so less interest is gained. Okay, the next thing we're going to talk about is car loans and mortgages, which work differently than credit cards because, why do they work differently? Couple things. So a credit card, come on camera, there we go. A credit card loan does not have a fixed amount of time that you're supposed to pay it off in, right? Like it's up to you how big you want your monthly payments to be and thus how long it will take to pay it off. But a car loan or a mortgage for a house, which a mortgage is a loan for a house, there is a fixed amount of time that you're supposed to pay it off in. Okay, so that makes the math a little bit maybe easier to figure out, what your monthly payment should be because you have some fixed amount of time in mind. Another thing is, let me write this down before I get too much further. Hang on. Okay, I'll write it this way. Fixed installment loans. Let's say it like this. Time is set. So that means there's some number of years that you're supposed to pay it off in. Also, the APR is fixed. So with credit cards, remember the APR could fluctuate. The APR here is fixed. So time is set and APR is set. They require a down payment typically. So if you are looking to buy a car or a house, typically you would need a down payment on the car or house. In fact, I know that for buying a house in particular, I'm not sure if this is how it works for cars, but for buying a house, the bigger your down payment, the less typically your APR will be. So I think the good rule of thumb if you're buying a house is you typically want to put at least 10% down, 10% of the total cost of the house, and if you can even double that, get up to 20% for your down payment, then you'll have an even lower APR. Typically that's how that works. But a lot of this, my knowledge is pretty limited on these sorts of things. I can teach you the math all day, and I can teach you what our book tells us, and the little bit that I know just from what I've researched. But if this is something that you're really interested in, you should know that this class is only scratching the surface, right? So you would want to go maybe take some other financial math class, accounting classes or something like that, or do some independent research on your own if you'd like to learn more about any of this stuff that we're doing here. Okay, so let's look at some math now. Okay. The amount of a monthly payment on a fixed installment loan is calculated with this. So PMT being payment, just like it was for those other formulas, it's going to be equal to P times R over N all over. So P is the principal amount borrowed. This is going to be the amount that you're borrowing for the loan. Over 1 minus 1 plus R over N raised to the negative NT. So there's a negative up there. So whenever we do our calculations, we're going to want to make sure that we get that negative in the parentheses of that exponent. Okay. Let's run an example that practices using this formula. Let me talk about it a little bit more, though, before we jump straight to an example. So what we're about to do with this formula is we're going to calculate what kind of monthly payment is needed for a fixed installment loan to be able to pay it off in some given number of years, right? So for a house, it could be, a long time, like 20, 30 years or whatever, and that would go there in the T. N is the number of payments made per year, so probably 12, right? 12 for monthly payments. R is going to be the APR. P is the principal borrowed, right? So if you make a down payment, so if the house costs $100,000 and you make a down payment of $20,000, then you only need to borrow the difference of $80,000. So you don't put the whole cost of the house or car right here. You put what is left after your down payment. Okay. All right. And since we're able to calculate it this way because for a fixed installment loan, the time is fixed, right? The time is fixed. The APR is not changing, so we can calculate what our monthly payment should be well, I was going to say easily, but relatively easily. A lot easier than if the APR was changing and if the time wasn't known. Okay, so let's see, is this example 2? So example 2 from the text says Kelly wishes to purchase a new car. The car she has chosen has a price of $34,000. So let's say Kelly is purchasing a car for $34,000. And that includes taxes and fees. Okay, so let's not complicate things by making you calculate tax and any fees independently. We'll just assume it's all squished into this one number. Kelly's purchasing a car for this much and making a down payment. So she's got a down payment of 20% of the price, and she wants to finance the remainder. So when you finance something, that means you take out a loan from the bank and get on a monthly payment plan. The remainder here being whatever's left, the 80% that she'll still need to borrow and get the loan for. So different size loans, not different size, different time length for loans will have different APRs. So let's say, I'll write it here. If Kelly has acquired a loan with an APR of 3.99% for 72 months. So typically when it comes to buying a car, you'll see like these kinds of numbers thrown around, 72 months or maybe 60 months or 36 months. Since when you're paying a car off, it gets paid off faster than a house, right? Because it costs less. So they tend to give these loans in terms of the number of months. Kelly has acquired a 72-month loan with an APR of 3.99%. What will her monthly payment be? Okay, how much is she financing? She is not financing $34,000. She's financing 80% of $34,000. Oops, there we go. Right? Because she's got a stack of cash that she's gonna put as a down payment. So she only needs to finance that remainder. Now, let's be honest for a moment. If you're putting a down payment on a car, are you thinking in terms of percentage of the price? Probably not, unless you just got a whole bunch of money laying around. Instead, you're going to think more in terms of the exact dollar amount that you're going to put as a down payment. You might say, I've got $5,000 to put as a down payment. You probably wouldn't think in terms of percentages, right? But this is just one extra little problem they threw at us just to remind us, I guess, how percentages work. So what we need to do, there's two different ways we could do this. We could do it as I've set it up here and just find 80% of 34,000, which would be to take 0.80, so this as a decimal, multiplied by 34,000. And so she is financing, and we'll just write this down, financing $27,200. That's what she needs to borrow. The other way you can do it is to find 20% of that and then subtract it. So find 20% of 34,000 and then subtract that from 34,000. Oops, what was it? 6,800. Either way works. It's just what I did is I said, oh, if she's making a down payment of 20%, then the remainder will be 80%. So that's how I did it. Or, it doesn't matter. Remember, we talked about this, doing it these two different ways in the percent chapter too. Just whatever you prefer. So this is how much she's borrowing. So that in our formula here will be P. Okay, so let's plug this stuff in. Okay. PMT is equal to, parentheses, 27,200 times R, which is the APR 3.99%, so written as a decimal is like that. Remember, to get that as a decimal, you type 3.99 divided by 100. There it is. Divided by N, which is 12 here, because we're doing monthly payments, over 1 minus 1 plus 0.0399 divided by 12, that same fraction there in the R over N, and then raised to, now I'm going to open my parentheses, say negative N, which is 12, times T. What is T, though? What is T? T is supposed to be measured in years. T is going to be 72 months divided by 12, because there are 12 months per year, so I need it in number of years. So T is going to be 6 here. Yeah, keep in mind that T is measured in years, so you do not want to plug 72 in there, because this is measured in months. This formula is built to be measured with that T being in years. Okay. So this is a formula that I do want you to know how to use, because it doesn't involve any logs, right? It's not much worse than the formulas we've already seen. So what am I going to do? 27,200 times 0.0399 divided by 12. So there's my numerator. And divided by parentheses 1 minus another parentheses. 1 plus 0.0399 divided by 12. Close that parentheses. Raised to another parentheses opening here, negative 12. So this negative button here, 12 times 6. Close that parentheses. Oh, I missed a bracket here. There's supposed to be a bracket, so I'll close another parentheses there. There we go. So her monthly payment, and that seems reasonable. It's in the hundreds, right? So, gotta cover this up. PMT is approximately $425.43. That's what her monthly payment will be. Cool. Okay, I want to skip example 3 from the text. I mean, it's interesting, but it's a little bit more involved than what I want you guys to be able to do. You can still read it; it's still interesting, and you'll see it's very much applicable to real life. I'm just skipping it because it's a little bit too involved for what I want you guys to be able to do. Okay. Example 4 is very similar to example 2, except now we're dealing with a house. Okay. So let's say, I'm not going to write it. We don't need to know the people's names and everything. Let me just say, you have saved $21,300 for a down payment on a house. And you're looking at a house that costs is $131,800, and this is including taxes and fees. So again, not complicating it by adding taxes and any fees that we need to worry about. Find the monthly mortgage payment. Again, mortgage just being another word for the loan for a house. Mortgage payment if the fixed interest rate, so the APR, interest rate is 3.52% for how long? For a 30-year loan, which in my experience, which is basically none except for reading things because I've never bought a house, I think a 30-year loan for a house is kind of typical. Okay. So, formula, right? I'm not ready for it quite yet. I need to find out what that principal should be. It's going to be, see, this seems a bit more natural. They know exactly how much. They're not thinking in percentages, right? They say, this is how much we have saved. So how much do they need to finance? 31,800 minus 21,300. This is what they need to borrow from the bank. That's going to be the capital P that goes in my formula. So PMT is equal to, so following this formula, capital P times R over N. So capital P is 110,500 times R, which is 0.0352 over N, which is 12. It is monthly payments, so N is 12 here. All over 1 minus 1 plus 0.0352 over 12 raised to the parentheses. Negative NT, negative 12 times T. T was given in years here, so no need to convert it. Like the last problem, T was given in months. Remember, it's a 72-month loan, but now this is a 30-year loan. No need to convert because it's already measured in years. All right. Oh. PMT is approximately, whoops, okay. So I'll say 110,500 times 0.035 divided by 12. That'll be the numerator, that's fine. And then divided by parentheses, 1 minus another parentheses, 1 plus 0.035 divided by 12. Close that parentheses, raised to, making sure I'm using my negation symbol and not the subtraction symbol. So negation of 12 times 30, close that exponent parentheses, close the big bracket, equals approximately 496.19. That's a good mortgage payment, I think, right? That seems pretty low, especially considering rent is around here is typically higher than that. Probably for a house that costs this much, like in Calhoun County, a house that costs this much, the rent's going to be like at least double that, probably. So, but then again, that's a huge down payment. What is that percentage? What is 21,300 as a percentage of this? So let's think about that. That's if I'm asking that question, just to see how good is their down payment relative to the actual cost of the house. I would do, how do I do that? I have to take this divided by that. So 131,800 divided by 21,300. Oh, no. I divided the wrong way. Sorry. This divided by that. And then times 100 to get it as a percent. So their down payment was pretty high. I mean, 16.16% was their down payment relative to the total cost of the house. So that definitely helped them out a lot for keeping their payments low, their monthly mortgage payments low. Oh, I'm saying they because in the problem in the text it's talking about a couple buying a home, but in this problem I called it you. So keeping your payment low. Anyways. All right. Okay, so I need to. I'm going to record the second part of this as a second video. It'll be short. There's only one more formula and then one more example for us to do, but I do need to stop because I have a meeting right now, so I did not time this well, so I'm going to have to make this 2 different videos. But I suggest that you read through those pages that I read through them with you, but it would be, if this stuff interests you, you should read through them through page 497, 498, 499, all the way through, because I did skip around, and just to make yourself a more informed consumer. Okay, next video I'll talk about maximum purchase price formula for buying a house. I'll run an example, and that will conclude all the material for this semester.